Welcome to the show. In today's episode, we are going to take a look at a molecular drill that does just the right amount of damage, according to the paper they wrote. Then we have an upgrade to bionic prosthetic limbs, makes them a lot more precise. After that, have you ever wanted to build your own full-size nuclear reactor? Well, if you have, someone went open source with all the plans to build a working nuclear reactor in your own city. And then we're going to wrap up with a good reason why robots aren't going to take our job anytime soon. I'm Zach. This is ZakDTV. And let's step into the Nano Drills. This one's pretty interesting. In a paper that was released by Rice University, they detail what they're calling a nano drill. This is a drill that has been built at a molecular level, piece by piece. It is a machine, but it is a nano machine. It's pretty amazing. It's built molecule by molecule. I know I said piece by piece. I meant molecule by molecule. Anyway, now these nano drills are just tiny little rotors that are activated by light. And when they're hit with the light, they spin up to 2 to 3 million RPMs. Very, very rapidly. Of course, they're thinking, what do you do with this thing? And that's when they stumbled on the idea, hey, let's use this to target cancer cells. And they did. Back in 2019, they released a paper on using this device to bore into cancer cells. They bore in through the wall and release all the inside stuff out. As you can see in this photo, that's actually seepage from this cell who's had its cell wall destroyed by a roving swarm of nano drills. And now let's take into consideration how small these things really are. You're looking at a cell and they don't even show up in the image. In fact, according to the people who are working on this, they say you can line 50,000 of these up in a row across the width of a human hair. That is how tiny they are. So in order to see them working, they have to set up special scenarios. Like here's one where as you see the color of the cell changing, that's a dye that has been able to move in through the cell wall because of all the holes that have been drilled into it by these nano drills. And basically at that point, you're looking at cell death. That's the end of it. Well, those researchers then thought, hey, this isn't enough of a supervillain type weapon for us yet. Let's try it on something bigger. And they did. They tried it on water fleas and a worm species called C. elegans. And as it says here on New Atlas, the nano drills caused the worm's skin to lose pigment, killing about 70% of them over the next few days. In the plankton, meanwhile, the drills cut off many of their external limbs, also killing the majority of them. Yes, these are little tiny drills that as long as they have light shining on them, they're just going to keep cutting deeper and deeper and deeper. If these little nano drills were just all willy-nilly and went after any type of cell, they'd really pretty much be useless. But researchers have found that they can add what's known as an addend at the end of these that can identify and attach to certain types of cells. This allows them to be targeted at a specific cell or a specific disease, a specific victim, if you will. This does take these drills from being a wandering weapon down to a precision strike against maybe cancerous cells or antibiotic resistant diseases, things to that effect, things that are harder for us to kill. On the other hand, I just feel like I'm talking about the beginning of some sort of targeted extermination device. Can you imagine if they can design this to be attracted to certain DNAs and wipe out entire bloodlines? No, for real, I'm joking. We're not looking at a weapon here. We're looking at the ability to deliver drugs directly to a cancer, maybe even kill cancer cells, bacteria, parasites, things to that effect with a mechanical means. And if we can just drill a bunch of holes in what ails us, maybe we could win the battle against cancer and other such things. I think it's a pretty cool development. Let me know what you think in the comments down below. Up next, we have an amazing advancement in the search for real functioning prosthetic hands. Researchers from the University of Michigan have made a major breakthrough in the control of prosthetic limbs. There are a lot of different bionic limbs out there right now, and they all basically run into the same problems. Sure, you can program them to do just about anything, but getting a human being to be able to make that happen is a lot more difficult. They read signal inputs from the nerves, but a lot of these signal inputs are very, very light and scattered by background noise. Well, what these researchers have done is grafted small amounts of muscle tissue into a package around the ends of the nerves. And that way, the nerves, when they are reacting, are actually causing the muscle tissue to flex, which provides a much stronger signal for the bionic attachment to pick up on. According to Cindy Chestek, she's an associate professor of biomedical engineering at the University of Michigan. She says that you can make a prosthetic hand do a lot of things, but that doesn't mean that the person is intuitively controlling it. The difference is when it works on the first try just by thinking about it. And that's what our approach offers. This technique allowed amputees to manipulate the fingers of their device without having to learn any new thought patterns, any new thought process. They just had to think about squeezing their hand, and it squeezed, just like their original limb would have been able to do. In fact, it was so precise, it even allowed them to play games like rock, paper, scissors. Well, they're doing rock, paper, pliers, they're calling it. I guess there might be a little bit of issue with making the scissors. But these people were able to manipulate blocks, pick up balls, zip zippers, and all that on their first time using this device. Another thing they found is even after a year of use, they didn't have to recalibrate. So this muscle graft just makes it intuitive to use these arms. According to Joe Hamilton, who lost his arm back in 2013, he said you can pretty much do anything you can do with a real hand with that hand. It brings you back to a sense of normalcy. This is early in the research. It's not perfect yet, but they do say they're going to keep working on this until they get to a point where it's no different than having a normal hand when you're using a prosthetic device. I find these kind of stories inspirational for the people who are living with this kind of loss, but I also think it'd be kind of cool. I'd be willing to give up an arm if I could get a super-powered Terminator style arm. It'd be worth it. This one, let me know what you would do. Would you give up an arm or a leg, or maybe two legs to have bionic powered running or something like that? Let me know. Talk to me in the comments down below. This next one sounds kind of nefarious, but I promise you it isn't. Open 100 Project, they're a subsidiary of the Energy Impact Center, has made open source all the plans you need to build a nuclear reactor. I'm not talking some little nuclear reactor ball for your backyard. No, this is a full-scale nuclear plant, every step of it, from containment chambers and vessels and control panels, full, right down to the details that you need to run a power plant. Yeah, I kid you not. And their plant design is supposed to last for something like 40 years. So these are real full-scale, let's make power happen type scenarios. Now, they did this with a good intention in mind. They want to see the world get off fossil fuels by 2040. And they figure instead of countries hoarding their data and not sharing with each other, well, why don't we take the best of everything that's around and make it free for everybody? And this way, everyone from investors to tinkerers to anyone else out there, state dictators, it doesn't matter. Doesn't matter if you're the leader of North Korea, Iran, whatever. You now have all the data you need to build nuclear reactors. That is honestly, in my opinion, a great thing. Because it's always been my standpoint, who are we to tell people they can't have this technology? If it's going to make their life better, everyone should have it. And this company just made that happen. I think it is cool. Now, I do have to say that when I went on their page and tried to look at the different stuff they had, I kept getting this. I don't know if their site is just real busy or if I'm somehow blocked from it, but I cannot get to the actual information. Links down in the description. You can check it out yourself, see if you can download the blueprints to build your own nuclear reactor. But for me, unfortunately, I can't get them. And now this last one, I have to share it with everybody. To me, it kind of exemplifies where we're at with robotics in reality. There's a lot of talk right now about robots taking your job.
Whatever happened to people jobs? They took our jobs!
Well, here are some of the most advanced robotics out there, trying to do something as simple as loading a pallet up with different boxes. As you can see, a human would be able to pick and place a heck of a lot faster. Now, this is a very cool robot. This is handled by Boston Dynamics, working with Auto, which is, as you can see, basically a forklift type of a device, a material moving type of device. And paired together, they're working pretty well. In reality, though, Handle is a lot cooler than this. Handle was originally introduced back in 2017, and here's some excerpts from the intro video. If you've been with me for a while, you might remember me covering Handle before. Yeah, that's right. Handle can jump on tables, jump over things. Awesome balance, quick movements. Looks a lot more agile than what they've made him do in that video from before, doesn't he? Yeah, it's kind of a sad day. But I'll tell you what, with robots moving that slow, I think humanity will have jobs for a little while longer. At least another couple years. And on that note, I am going to call it a day. Thank you for stopping in. I'm going to go enjoy my weekend. If you enjoyed this episode, make sure to click that like button. Share it with your friends. Leave me comments. Help this channel grow. That's what it takes. It takes interactions. The more you interact with this channel, the more it will help me grow. Now that I've done enough begging, just, have fun, enjoy your weekend, and be safe. I'll see you guys next week.